Okay, YouTube, in this video we're going to introduce the concept of a hyperbola. In the past we've studied, in terms of conic sections, circles, ellipses, parabolas. In this last video we're going to explore what we call a hyperbola. And what we're going to start with is basically the general premise of what a hyperbola is. So what you see here, I've actually constructed a hyperbola. It is some conic section here that essentially has a center, and we're going to say that the center is at some h and k. But we'd say that given this center and some transverse axis that runs either horizontally or vertically through the center, we see that we have two what we call vertices here that are located on this hyperbola. Okay, and then the foci, instead of being on the inside like you see here between the vertices in the center, like you see that with an ellipse, okay, the foci are actually located as these green dots on the outside here. So the interesting thing is that our conic section still opens towards the foci, but the foci are on the outside of the vertices in this case. And so the basic definition of a hyperbola is the set of all points here, x, y. So we're going to say that this letter G here, this point G that's purple, represents some point x, y, but if you were to find the distance between it and one focus, we call that one focal chord, and then we find the distance between it and the other focus, and find the difference between these. Now, not the sum between these two values here, but the distance between these two, or the difference between them. You notice that 7.18 minus 3.18 is 4. And no matter where I go, wherever I stretch this point here, 10.53 minus 6.53 is still 4. But basically, the difference between those two quantities right there, no matter what point you pick on this, is going to be a constant. And just to let you in on a little secret here, as a matter of fact, we said that in the past the distance A, when we talk about A on an ellipse, it's the distance from the center out to a vertex, where the distance C is the distance from the center out to a focus. In this case here, we would say that this distance A is 2, since we go 2 units to the right from the center to get out to a vertex. 2 times that value there, which is 4 in this case. That's the constant you'll always get when you subtract these two focal chord lengths. So basically, that is what a hyperbola is, and that's what they look like. What I want to do is I want to visit the standard form of the equation of a hyperbola. And basically, some common things in terms of anatomy I want to share with everybody are these. We say the standard form of the equation of a hyperbola with a center at h and k. So we say h and k is our center, just like with an ellipse. But it's this, and you'll notice here that this looks just like an ellipse, except for the only difference is, and pun intended here actually, it's a difference. It's not a sum between these two values, it is a difference. So the first thing I want to mention here is it doesn't matter what order you subtract in. So you'll notice that in either instance here, the a squared and the b squared, it doesn't really matter where they're sitting, it's what's up top. And what I notice up top here is when I say x minus h squared minus this quantity y minus k squared, all this is 1, and over their respective quantities here, I notice that x came first, or it comes first here, whereas down here y comes first. And then, like I said, it makes a difference. So when we talk about differences here, where the x term comes first, we're going to say that the transverse axis is horizontal. And you think about x as being horizontal anyways, where as if y were to come first, we'd say the transverse axis is vertical. And so in terms of orientation, we say that the transverse axis, let's go ahead and revisit the anatomy here. You'll notice that we have two sets of hyperbolae over here, and I'll write their equations again next to them, but you notice that the x term comes first here. So I remember when I said that we have an x orientation here. The thing I kind of remember is that this hyperbola here looks like the letter x to me. It kind of does this, looks like the letter x. Whereas if y comes first, I would say that it's vertically oriented in terms of its transverse axis. And I kind of look at it as being something like this with the transverse axis here. And I look at this and I kind of see the upside down letter y and the letter y. However you want to remember this, it all relates back to the transverse axis. So the transverse axis, let's go ahead and get to it. We say that the center is located at h and k on either figure here. And so we would say that we have 2 points here on the transverse axis that intersect the actual object, the hyperbola itself. We say that these are vertices. Okay, so our vertices are here. And then we would say that these 2 points here, let me switch colors for us here, are the foci. And the foci are located outside, I would say, the vertices, but inside the conic section itself. So we have 2 foci. And in terms of values here, I'm going to put a few in, but in the past we notice we have A and B, whereas we say A. We would say A is, in an x-oriented thing here, we say A is the distance I would go left and right from the center. So we would say left and right to get to a vertex is this distance A. Now, this distance B, which we're used to going up and down with an ellipse, we would say that there's this imaginary distance B, and it goes up and down from the center, and it goes out to some point that's not even on the conic, but we're going to get into some videos here where we say we can make a box around this, and it's really helpful to graph these. But essentially, we would say the distance from the center out to a focus is C. So we say C is the distance from center to the foci. And then we would say A and B are these distances, A or B, distance to vertices, and the endpoints. I'm going to write it this way. It's really weird. The endpoints of an imaginary axis perpendicular to the transverse axis that cuts across our hyperbola here. Okay, we could either have a vertical or horizontal or a vertical transverse axis. Okay, so knowing all of these things, I just kind of want to put this together here, and I'll make a really quick set of notes here. But basically, if you are centered at 0, 0, h and k drop out, and you basically get these diminutive forms of them. And then we say also the relationship between a squared, b squared, and c squared is thus, and we say that it is directly Pythagorean if you want to look at it that way. Okay, so in terms of how you can remember it. So we say c squared equals a squared plus b squared, where c is the distance from the center to the foci. So let's go ahead and take a look at an example where I'm going to tell you first things first, whenever you get clues, you need to sketch them in. So it says find the standard form of the equation of a hyperbola with foci -1, 2, and 5, 2, and then vertices at 0, 2, and 4, 2. So the first thing I'm going to do is I'm going to draw in what I know here. So the foci are -1 up 2, so we say here's a focus. And then we say 5, 2 would be 5 to the right here at the same height. So we say a focus and a focus here. So I already know that our transverse axis runs left and right. And then we say I have vertices at 0, 2. So this is going to be a vertex here. And then 4, 2 would be on this other side here. So we say that's a vertex and that's a vertex. I'm going to kind of label those out. So we say, well, I know that the center must be here. And this is the point 2, 2. So in terms of the grand scheme of things here, we already know h and k to be 2 and 2. We just need to know A and B if we're going to write the equation of this. And I think we know C here. So I'm going to write all this in. And then the other thing I'm going to write in is basically this. We say in terms of the equation, we're going to get something that looks like this. And I know that since our transverse axis runs horizontally, that our x value must be the value that comes first here. So all we're going to do is we're going to plant in these values that we need to know here. Starting with now, h and k, I say we can put in a 2 and a 2. We just need to know A and B. So in terms of A and B here, okay, well, I'm going to say A. A is the distance from the center, okay? In this case, we could say this is A and this is B here, but A being underneath the X thing. That means that it's the displacement in an X direction to get to, like, say, the vertices. So I say, in this case, I say 1, 2. It took me 2 spaces to get from the center to a vertex in an X, displacement or horizontal displacement. So I'm going to say 2 here. And then in terms of up and down, I don't know what B is. I really don't. So I say I know A is 2, but I do know that C is the distance from here always to a focus. And we say that that distance here is 3. So in this case, I get 3 squared, which is our C value squared, is equal to A squared, which is 2 squared, plus B squared. So in this case, I get 9 equals, I'm already thinking ahead here, 4 plus B squared. And so we'd say then it follows that B squared is equal to 5, and B is root 5. So we could say if I went up and down root 5, I would actually get to the ends of some imaginary, axis here. But basically, in terms of sketching this, if I wanted to find what this actually looks like, I would give like a rough sketch that would look something like this here. And it's not going to be beautiful, but it does have to go through the vertices, and it has to open towards the foci, but this would be our hyperbola here, and this would be its standard form equation right there. So that's what a hyperbola is. In the next video, we're going to talk about how we find the asymptotes that this hyperbola actually approaches. We can sketch it a whole lot better. Cheers.